We're looking at what is the midpoint voltage in volts for a CMOS 2-input NOR gate with the following values here. We can assume simultaneous switching. So for this, we are going to use the following equation that we have here. It's in the notes in the description below the like button. Hope they help. But we're going to use this to find the midpoint voltage. So hopefully this will help you with that. For something like this, it's pretty straightforward. We're just essentially going to be plugging everything in here. So we have our VDD, this right here, and I'll solve it for this problem. Your values might be different, but again, this is just going over the concept for it. So VM, which is the midpoint voltage, is equal to VDD, which is 3.3 volts, minus the absolute value of our VTP. And our VTP is going to be this negative 0.7. So inside of here, we just have a negative 0.7 in absolute values. That means it's going to become a 0.7 afterwards, plus N. Now, N is essentially how many inputs you have right here. So since we have 2, this is going to be a 2 input. So this is 2 and this is 2 for this problem. Make sure you're careful about which one you're using for your problem. So we have plus 2. Next, we have something pretty interesting. It's the square root of our beta N over our beta P, and then it's multiplied by our VTN, which for this problem is going to be 0.7. That's outside of our square root. So let's find out what our BN, or beta N, and our beta P's are. So beta N is going to be the following. These are also in the notes, but I'll just write it out here. Beta N is going to be equal to our K prime N multiplied by W over L of subscript N. Okay, and beta P is equal to K prime P multiplied by W over L and then P. So very similar for both of them. Can't really get them mixed up. BN, beta N, and beta P. You can solve those that way. We're given WLP, we're given WLN, and then we're also given K prime P and then K prime N. Make sure you're accounting for units. I don't think they make that big of a difference for this problem, but that's just something to note for that. For our specific problem, for our beta N, I am going to get approximately 0.00686. And for our beta P, I'm going to get approximately 0.003148. So now what we're going to essentially do, just plug this one, the top one, beta N, right here, into here. And then we're going to plug our beta P into the denominator right here. And we're going to copy this and put it in the denominator just to solve for the rest of it. So we are going to be dividing by this. We're going to take this, we're going to copy it, and then we'll just paste it down here, move it down, and then we just have a 1 plus this. So we have 1 plus all of this. It's going to solve for our equation. Once we plug in our values, we plug this into a calculator, everything should be good. And for this specific problem, we're going to get that our VM is equal to approximately 1.8869. And that's how I would personally go about solving it.